welcome back to 11.5. The next thing we're going to look at is lots of application problems. And these applications, as you can probably guess, are going to lead to some quadratics. So, first application I have for you in example 2 says that there are two cars. They left an intersection at the same time. One heading due south, the other due west. I'm a very visual person, so I'm going to draw this, okay? So here's the intersection. One of them is going due south, and the other car is going west. Okay. Sometime later, they were exactly 150 miles apart. Okay. So that's quite a lot of driving for both of them. So this distance from this car to that car is now 150 miles. Okay. The car headed south had gone 30 miles farther than the car headed west. So this car that went west, we'll just say that it went X miles. So then the one going south did 30 more, so X plus 30. How far had each car traveled? So we're going to solve for X and we're going to solve for X plus 30. We're going to answer both of those. So looking here, I can tell you that south and west, they are perpendicular to each other, so we do have a nice little right angle here, and it might kind of become obvious here that we have a triangle, and it's a right triangle, and we're solving for sides of our right triangle. Hopefully, the first thing that comes to mind when you're like, hey, we have a right triangle and we're solving for sides, is that Pythagorean theorem, a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. So for us, what that's going to look like, a squared, you can use either one of the legs, but how about x squared? For b squared, we'll use the other leg, so x plus 30 squared. And the hypotenuse is always the side across from the right angle. It's the longest side of the right triangle, and that's our 150. So 150 squared. That's what this would look like into the Pythagorean theorem, okay? From here, it's just equation solving. So x squared, of course, is x squared. X plus 30 squared, just reminding you, that's the same thing as x plus 30 times x plus 30, and you're going to need to distribute that. So x times x is a positive x squared. X times 30 is 30x. 30 times x is another 30x. And 30 times 30 is 900. All right, on the other side, let's see, we have 150 squared. So 150 times 150 is 22,500. I think we can combine some like terms and at least get everything on the same side. I notice at this point I've gotten x squareds. So I notice at this point that it is going to be a quadratic equation. So I'm going to go ahead and subtract 22,500 from both sides so that it equals 0, and we can get things in standard form. X squared plus x squared are like terms. That'll be 2x squared. 30x plus 30x is positive 60x. And if I do 90 minus 22,500, or sorry, 900 minus 22,500, I get negative 21,600. I can make my life slightly easier by just saying, hey, wait a second, everything's divisible by 2, and we can kind of get those values a little bit smaller by dividing both sides of our equation by 2, if you'd like, to make your life a little easier. Then we'll have an x squared, that'll be a 30x, and 21,600 divided by 2 is 10,800, and 0 divided by 2 is 0. So that makes it a little bit easier. This might factor, but I don't feel like looking at multiples of 10,800. That seems like a long list. So how about we just go right to the quadratic formula. So x equals, that would be the opposite of b, so negative 30, plus or minus the square root of b squared, so 30 squared, 30 times 30 is 900, minus 4 times a, which is 1, times c, which is negative 10,800, all over 2a. 2 times 1 is 2. Alrighty. So from here, if I do 4 times 1 times that negative 10,800, and then we do 90 minus that, or sorry, 900 minus that, you're going to get the square root of 44,100. This negative times a negative will be a positive, so you're adding that 4 times 10,800. So you're going to add that value and 900 together. That's where this comes from. It's all over 2. That 44,100 is actually a perfect square, believe it or not. It is the square root of 44,100 is 210, which is pretty nice. We're all over 2. So to get our 2 answers, let's see, we're going to do negative 30 plus 210, which would be 180 over 2. If we do negative 30 minus 210, I'm going to get a negative answer. And just looking at the context of our problem, that does not make sense to have a negative distance. I mean, it headed in a different direction, and I am assuming that our problem is telling the truth and that the cars honestly went west and went south. They didn't go the other direction. Okay, so this is going to be our only answer that makes sense. And 180 divided by 2 is 90. So I think it helps to go back to our picture because we want to say how far did each car travel? Well, I just got x equals 90. So if I go back over here to our picture, the x was the west car. So the car that went west went 90 miles. The car that went south went 30 more than that, so x plus 30, so 90 plus 30 would be 120. So 120 miles. And we can answer that in the context of the problem and answer the question completely. All right, let's do another one. So that one was a Pythagorean Theorem problem. Our next one is going to be an area problem, okay? So this one, example 3. We have a rectangular reflecting pool in a park is 20 feet by 40 feet. So this is not one of those pools that people swim in. It's just like a pretty one. It probably has like a fountain in the middle or something nice. So we've got this rectangular reflecting pool. And again, I'm very visual, so I'd rather draw a picture to illustrate what we have here. It's 20 feet by 40 feet. Okay. The park gardener wants to plant a strip of grass uniform width around the edge of the pool. Alrighty, so he's basically going to make a little rectangle around the pool like this. And it's a uniform width. So this, like the whole, every single width, however you want to measure it, they're the same. Okay? And this whole area is going to have grass. Alrighty. Just going to shade in some grass here. Okay. He has enough grass seed to cover 700 square feet. How wide will the strip be? Alrighty. So basically what it's telling me is that the area of this grass region is 700 square feet. Okay? So let's talk about how do you kind of calculate the area of the grass region. Well, first off, we need to find the width. So let's just say the width of the strip, we're just going to call it x. Okay, and that width is the same whether it's to the left, to the right, above or below, all directions, it's still x. Okay, so the area, that's 700 square feet, that's the area of the grass, which basically is the area of the whole thing, the big rectangle, so the area of the big rectangle minus the area of the pool, because we're not going to put grass seed in the pool. We're just going to put grass seed around the edge here. Okay? So, the area of the big rectangle, it's length times width. So my new length, instead of being 40 feet, we added an x to the left and we added an x to the right. So the new length will be 40 plus 2x because we're adding it twice, to the left and to the right. The new width, instead of being 20 feet, we added an x above and an x below, right? So 20 plus 2x would be the new width. minus the area of the pool. The area of the pool is easy to compute. That's 40 times 20. Length times width. Alrighty. Let's go ahead and simplify this and get it solved. So from here, I distribute 40 times 20 is 800. 40 times 2x is 80x. 2x times 20 is 40x. And 2x times 2x is a positive 4x squared. Minus 40 times 20 is 800. We have a lot of like terms, don't we? Also, we notice that it's a quadratic because I have an x squared term. That's my highest exponent. So let's go ahead and get everything to the same side. So I'm just going to subtract 700 from both sides so that it's equal to 0, and we can be in standard form. I like to go in order. I like to go highest exponent to lowest. So my highest exponent is the squared term. That's the 4x squared. And then the next would be my x's. So 80x plus 40x is 120x. And then the constants, 800 minus 800 is 0. 0 minus 700 would be negative 700. Okay? From here, well, these look like big numbers. Let's just go right to the quadratic formula and let's see how that goes. X equals the opposite of b, so that would be negative 120, plus or minus the square root of b squared. So 120 squared is 14,400, minus 4 times a, which is 4, times c, which is negative 700, all over 2a, so 2 times 4 would be 8. All right. If you simplify what's in the square root, that negative times a negative will give you a positive, so it's going to feel like you're adding in here. You're going to do 14,400 plus 4 times 700. If you simplify inside the square root, you're going to get 25,600, and it's all over 8. And that happens to be a perfect square. Hooray. So the square root of 25,600 is 160. It's all over 8. And so then we have our two answer choices. We can do negative 120 plus 60, which gives you 40, divided by 8, which would give you 5. Or you could do negative 120 minus 160, which would give you a negative answer, which would give us a negative width, which just does not make sense in the context of our problem. We should have a positive value for our width. So the only answer that makes sense in the context of our problem is x equals 5. So the width of the strip should be 5 feet. Now it's your turn. You guys get to try one and show me how much you've learned.